Hi, I'm Mrs. Burns, and welcome to 6.2, the second lesson in our Chapter 6, and actually already the last lesson of Chapter 6. So a little review, we learned last day about 6 types of chemical reactions, so please make sure you know all about synthesis, decomposition, single replacement, double replacement, neutralization, and combustion. So today we're going to learn about how to speed up or slow down some of our chemical reactions. So when we are talking about how fast or how slow, we call this the rate of the reaction. Or sometimes you might say the reaction rate. So that's just talking about how long it takes. If it has a fast reaction rate, it happens quickly. If it has a slow reaction rate, it happens slowly. So a few ways that you can alter the reaction rate, how fast your reactants are coming together to make your products, are through temperature, concentration, surface area, and with a catalyst. So let's look at temperature first. Typically, when your temperature increases, then your reaction rate increases. I just say typically because sometimes you can increase the temperature so much that you actually can denature certain proteins, and so sometimes temperature doesn't I just say typically because sometimes very, very, very high heats can actually destroy your different elements or compounds, especially if you have protein, something in your body. So this is because the kinetic energy is increasing as we increase the temperature. So the faster the molecules are moving, the faster they're going to collide together. And when they collide, these two reactants, that's when you form your different products. So we want these collisions to occur. You get more collisions when it's hotter, so let's turn up the heat a little. You can also increase your rate of reaction with the concentration, and concentration is just the amount of particles in a given space. So the more particles there are, the higher the concentration is said to be. So it's like if you're spread out, just our class in the whole school, we're really spread out low concentration in that space, but if we squish us all together into the classroom, we're bumping together a little bit more closely. It's a higher concentration, more people in a given space. The more particles there are, the greater there's a chance of a collision for your reactants to come together. Thus, a higher concentration increases the reaction rate. You can also influence this by the surface area. Think about a big sugar cube versus all of your little grains of sugar. Which one dissolves faster? So the surface area is just talking about how much of that is exposed. So of one big cube, only some of the outside is exposed, but all those little grains, so much more sugar is exposed. So the more surface area you have, the more chance that something will happen. So the greater the surface area, the greater the chance of a collision or reaction to occur. So a collision, remember, reactants coming together. So an increased surface area increases the reaction rate. Finally, a catalyst can help speed up your reaction. A catalyst is something that's non-living that will speed up, so it speeds up the reaction rate. Now, a catalyst is not actually used up in your reactions, so therefore we don't actually write it in the chemical formula. It's just used to help it out. So they lower the energy that's needed. So if you need this much energy in order for the reaction to occur, now with the catalyst you only need this much, so it's more likely it's going to happen because you don't need as much energy. So they also can help line up your reactants in a certain way so that they fit together really well, so those reactants will really join nicely to make your products. Alright, those are some ways we can change our rate of reaction. Please study that, and we will see you tomorrow.